All right, guys, my take on this 1.3 assignment here. Wanted to tell you about some stuff, just some perspective I felt like you could use from me. Okay, number one, it says match each side as hypotenuse, opposite, or adjacent of angle B. And so it's kind of just a matching one, as you can tell. One thing we should know about this stuff in trig is hypotenuse is always this slanting side. I'll put HYP for hypotenuse. It's the one that's across from the right angle is the proper way to define it, opposite of the right angle. But what what I meant to do. Also, you could think of it as the slanty side, although not, if you twist around this triangle, it may not look slanty, Anyway, it's the one that's not part of the right angle. Here we go. Here's the right angle. These two sides make the right angle. Here's the hypotenuse side, So that's an easy way to identify hypotenuse side, regardless of anything about angle B. That's never going to change. They could be talking about angle A, angle B, angle C. It doesn't really matter. These other two things about opposite and adjacent, they'll be relative to angle B. We'll talk about that. Hypotenuse is never changing. So if hypotenuse is this slanty side here that's not part of the right angle, that's going from point A to point B. And so that's how we will identify hypotenuse. In this case, we'll say the hypotenuse, the slanty side, is the one that's, we would identify it as segment AB or something like that. And so here we go. Hypotenuse, we'll say, is AB over here, which is ironically option C, it's whatever anyway. And so hypotenuse is this one, it's from A to B. Okay, here we go, hypotenuse. Ta-da. Okay, now to identify the other ones here, let's get a new color on it. Here we go. To identify the other sides here, they say opposite and adjacent of angle B. And so those ones are important it's important in those cases to recognize they're referring to angle B here. And so if we're talking about opposite and adjacent, they're saying opposite of angle B, adjacent to angle B, And so, let's clear some of that drawing up. So we had hypotenuse over here. That's not going to change. But then for the other ones, we'll notice that they're talking about angle B. So let's emphasize angle B in our drawing and say, okay, here's angle B. If that's angle B, then opposite of angle B would be the side that's across from angle B. And so when they say opposite, they mean opposite of whatever angle they're talking about. So since they're talking angle B, across from angle B, that's the opposite. OPP for opposite, or you can just put O for opposite sometimes, but it's weird. So it looks like a zero, whatever. Okay. And then besides that, we'll have adjacent here. And so adjacent, you may, it's not a real popular word these days. It just means next to, is one way of saying it. It's right next to angle B. And so that means, well, if it's not the hypotenuse and it's not the opposite side, it must be this side, anyway, it's the leftover one is the way people say it, but we would see ADJ is adjacent there. That is from here to there. That side is adjacent to angle B. And so that's how we'll answer these things. When they ask for opposite, adjacent, and hypotenuse, opposite and adjacent are going to be across from the angle and next to the angle. And the hypotenuse is just always it's always the hypotenuse, no matter what angle you're talking about. So answer that accordingly. That's what's going on with those. Okay, clear that off. Let's look at some other stuff here. It gets a little bit more intense than that. Let's talk about some of this stuff. Okay. On number 2, they give us this, it's a right triangle with sides 4, 5, and 6. I don't think that that's possible. 3, 4, and 5 would be believable. This is not a Pythagorean triple, which means this is not actually a right angle. But who cares, Let's just suppose. And so, because 4 squared plus 5 squared doesn't equal 6 squared, and whatever. At least I don't think so. 16 and 25, right? Anyway, so pretend like it doesn't really matter. Okay, so we have 4 and 5 and 6. Here's what they ask us to do with this. They have their stuff labeled as A and B and C, and this is angle C, angle A, angle B, and here's all the sides in between. They want to know. And they make the note here after I picked on them. It says it's not drawn to scale. Who cares? Anyway, I shouldn't have been nitpicking. But in right triangle ABC above, what is the sine of A? And that's the first time we're seeing this term mentioned, well, what the heck is sine, and stuff. And so let's talk about that real quick. in trigonometry, I don't want to overdo it because this is, let's keep this video short. We can talk more when we're together or something, but, and okay, there we go. In trigonometry, we're really oftentimes comparing just sides of a right triangle is a real quick way of introing the idea. And the motivation behind that, we'll talk more about when we get the chance. There's reasons why we study this stuff. And it actually has to do with more like rotation and circular relationships a lot of the time. And there are triangles hidden within that, Who cares? Right. Here's the idea here. There are three ratios they'll ask about. Sine is one of them. That's a real popular one. There's actually more than that, but the three popular ones we'll start off with is the sine ratio, the cosine ratio they'll ask you about, and the tangent ratio, And here's what they're saying with those ones. If you had a right triangle, say, like we have over here, there's a right angle in it. And suppose I wanted to focus in on some angle here, because like they're saying in ours, the sine of A, they're saying, well, let's focus in on angle A, And so what goes on with the sine ratio, or with all these three trig ratios, is we'll say, well, depending on which one we're asking for, and again, that'll depend on the situation, but for now, we'll just say, depending on which one we're just asking for, suppose we had no motivation at all. Well, each one of these ratios, this is short for cosine, and this is short for tangent. I should have written the whole word. Each one of those is going to have a different definition to it, where we're just comparing the length of each side of these things, And so sort of what goes on with this case is, well, let's suppose I had a 3, 4, 5 triangle, right? 3 squared plus 4 squared is 5 squared. So this is a Pythagorean triple. It's a right triangle. Okay, and so we would say the sine of angle A, if I labeled this angle A, say, in this case, not so much, we haven't gotten to this one yet, but in our little triangle over here, on the right-hand side, the sine of angle A would be what we define to be the opposite side of A compared to the hypotenuse of A, How big is this side compared to the hypotenuse, So the sine is 3 over 5. Ta-da! And you just say it's a 3/5 ratio or a 0.6 ratio. If you want to put that in decimal form, 3 divided by 5 is 0.6, ta-da, or 0.6. The cosine of A is just comparing different sides. The cosine we define to be the adjacent side compared to the hypotenuse, And so that's 4 compared to 5. So the cosine ratio says that, well, essentially what we're saying here, when I say cosine, it means that the over part here is almost as big as the hypotenuse. It's 4 out of 5, or 0.8 if you make that, 80% or something. It's 0.8 as a decimal. And then the tangent ratio is us just comparing the opposite side of A, the one across from A, to the adjacent side of A. And so that's 3 or 4. And so we can leave that there, or of course you can decimal it at 0.75, And so this is the way we define sine, cosine, and tangent. It's easy to mix up which is which. So a lot of people will use this, it's a mnemonic device, a memory device to help keep to keep the definition straight. You'll probably will refer to this a lot. So this would be a good thing to get down. If you say sine, cosine, and tangent, which one is which, what do I compare to what? And so the way we remember that is we'll say, the most popular way that you'll ever hear is what they call the Sohcahtoa approach. And we'll say sine, cosine, tangent. Sohcahtoa is this little, it's a mnemonic device, which reminds us that the sine ratio, obviously S is for sine, is comparing the opposite side to the hypotenuse side, or it's like opposite over hypotenuse, And then the cosine ratio, see, it looks like it's 0. Then the cosine ratio is comparing, it's an A for an H, So ka is comparing the adjacent side to the hypotenuse. And then the tangent ratio, if they ever ask for the tangent ratio, is comparing the opposite side to the adjacent, opposite over adjacent. So this would be an easy way to keep it straight. You'll find this all over the internet. It's the most popular way that I've ever heard anybody try and remember that stuff. None of the other ways are even coming to mind. I don't know of any other popular ways other than just remembering stuff, Anyway, but I'm sure there are. If we look back to the historical roots of these things, we can find some other things. But so now we got Sohcahtoa. If they ask you for a sine ratio, they're saying give me the opposite over the hypotenuse. And so we'd say, here's the sine, here's my angle A, opposite of that over the hypotenuse, which is 5. So that'd be 3/5. Like we said, the adjacent over hypotenuse is like we said, here's the adjacent side of our angle A. And then the hypotenuse is 5, so 4/5. And then TOA tangent is opposite over adjacent, 3/4. Okay, that being said, when they ask you stuff like that in the homework, now we'll know what to do. And so, there we go, check this out. Okay, so they say in triangle ABC above, what is the sine of A? The sine ratio, we know from Sohcahtoa, sine is opposite over hypotenuse. So we'll say, okay, angle A is the one they're referring to. So let's color in angle A so we know which angle we're to look at. Because if they said angle B, it'd be a whole different set of ratios. What's opposite of A is not the same thing that's opposite of B. So just be careful of that. Make sure you pay attention to what angle they're talking about. Sine of A means here's A. Here's what's opposite of A across from A, right? Is the 4, or the side that's length 4. Adjacent to A is this other one that makes the what do we call it? The right angle. Adjacent to A or next to A, that's that one. And then hypotenuse is always hypotenuse. It's the one that's across from the right angle. Okay, this is across from the right angle, so it's the hypotenuse, no matter what angle you're talking about. We have these all labeled up now. So for sine of A, if we're looking at angle A, we can get any ratio they ask for now. We can say the opposite, the adjacent, the hypotenuse, use any of these to use the ratio we want. But now, if they're asking for sine, we know that sine is opposite over hypotenuse. So let's look for angle A, opposite is 4, and the length inside opposite is 4. And the hypotenuse, the length of that is 6. So we have a 4/6 ratio. And you can reduce that to 2/3 if you like, although it looks like multiple choice. They didn't do that, Anyway, that's what we're looking for in that one. Moving on. Boom. On number 3, they're asking which trig function, or which trig ratio, you could say, which trig function would you use to determine, or I'll just read it. Would you use if the above information was involved in the problem? And so we'll dig this. Okay. They're saying which trig function, you have to pick which one, sine, cosine, or tangent here. Well, that's going to depend on what's labeled up, and so the only angle I'm noticing they're emphasizing is angle B. Because you notice over here, there's no letter mentioned. There's no letter on that one, although obviously it would have to be a C because it's by the right angle. But the one they're emphasizing is angle B. So we have to do whatever we label on the sides. We're labeling them with respect to this angle B because the other angles are not really emphasized, Okay, so we're looking at angle B. Then let's label things up. And notice that this side opposite of B doesn't have anything on it. Here's opposite of B. There's no number there. There's no letter there emphasizing. So really, I'm not doing much with that. So that's opposite, but we're not going to use it because there's nothing there. What they do give you is, well, here's the side adjacent to B. Whoa, pretend that says adjacent. Here's the side adjacent to B. And then this slant side here is the hypotenuse like usual. Well, now we got to pick a ratio that uses adjacent and hypotenuse. And so then if we just look back on, let's work on the penmanship. We just look back on Sohcahtoa, then we'll just figure out a ratio that uses adjacent and hypotenuse from those 3. And so adjacent and hypotenuse, that's A and H, it looks like it's the cosine ratio that uses adjacent and hypotenuse. So we'll just choose cosine, that's how I would do that one. Cool. All right, next up. Oh, I forgot to erase that stuff. We'll erase it in a second. Okay, number 4. Oh, yeah. So, match each trig function with its ratio. This is from Sohcahtoa. I would just use Sohcahtoa to match these up. Tangent is, like we say, I won't take you through the whole thing on this one, but sine, cosine, tangent, And so we're like, oh, tangent ratio. If I think Sohcahtoa, tangent is opposite over adjacent. So then, there we go. Opposite over adjacent. It's that one, And that's all you would put for that. Okay. And then just keep going with that. Okay. Number 5. We got 3 sides given. What's the sine of A? That's like that other one we did before. Here's side A, label it up, and then figure out sine is by Sohcahtoa. That's going to be opposite over hypotenuse again. Don't feel like you have to remember that, but just look it up in Sohcahtoa again. Sine ratio is opposite over hypotenuse. It's 4 for 10, and then wham, Same kind of thing. Which trig function would you use? We did a one like that already. And then another one of these. Find the sine, cosine, and tangent of angle T. And so this one's asking for all 3 of them. We haven't done one like that yet. So let's try one like that. Okay. Okay. Angle T. Here's angle T. If they're referring to angle T, let's color it in there and emphasize angle T just like they did. Now let's label up all the stuff. Okay, so hypotenuse is always hypotenuse. We can label that even if we don't know we're talking about angle T. So there's hypotenuse. Opposite of angle T is this from U to V is 12 units across. So then here we'll call that side opposite. And then that means this one is adjacent because it's next to our angle. And so then from there, let's see if we can find the sine, the cosine, and the tangent here. The sine, and notice they want them in that order, the sine, then the cosine, then the tangent, because of course, they're mixing all these things up, sine, cosine, and then the tangent. Well, let's see what we can do. Okay, sine, here, I'll put the whole word, cosine, tangent. Okay, well, we know from Sohcahtoa, let's keep that around somewhere. So, whoa, we know how to handle this. And so we'll say, well, the sine ratio, that's the opposite over the hypotenuse. So here we go. Here's angle T, opposite over hypotenuse would be 12 over 14. And the cosine ratio, well, cosine is adjacent over hypotenuse. So let's see, adjacent over hypotenuse is 8 over hypotenuse is 14. And the tangent ratio, tangent is, let's look. Tangent is, okay, so TOA, so that's opposite over adjacent. That's opposite over adjacent, so 12 over 8. Looking good, then we just reduce them all, fractions wise, let's see here, 2 goes into both of those. This is 6 out of 7, and reduce those. And we got ourselves some answers. That's how I would probably handle that one. Okay, next deal. Suppose we have these things, enter an exact value, report as a fraction. So here we go. Let's at least do part of this one together. I think trouble getting this to move. There we go. Okay. Suppose that A is 95, B is 168, and C is 193. Let's label them up. A, we'll just put 95 here. Whoa, I don't have this working. Okay. 95. B is 168. C is 193. And then here we go. Look at this. They're asking for sine of A, cosine of A, tangent of A, secant, cosecant. We got a bunch of these things. Cotangent, I'm going to assume it says under there. I can't see what's going on recording. Yeah, cotangent. So we get to introduce to a few of these other ratios at this point. So I guess we should do them all real quick. Let's talk about all that. Okay, the first 3 are everything we're used to. First off, they're referring to angle A, so let's go ahead and highlight angle A, emphasize that so we can refer to those appropriately. And so, okay, if here's angle A, then we know across from it is what we would call opposite. Maybe I'll choose different color. Okay, opposite of angle A. And then adjacent to angle A would be this other one that makes the right angle, so that's called adjacent there, adjacent. And then the hypotenuse is just a hypotenuse all the time. There's that 193 segment there. Okay. Now, sine of A, cosine of A, tangent of A, let's figure those out real quick. Color orange or something. Let's see how this goes. Okay. Sine of A, we know from Sohcahtoa, so pretend you can read that. Toa. Some A there. Sohcahtoa. Right. Well, here we go. Sine is opposite over hypotenuse. And so let's see here. There's the opposite. Opposite is 95, or hypotenuse 193, done. 95 over 193. Ta-da! And then cosine, well, that's adjacent over hypotenuse. So 168 over 193. 168 out of 193. And then tangent ratio is opposite over adjacent. So that's what is that? 95 opposite over adjacent 186. So 95 out of 186, comparing those two sides. Kind of like we've been doing, you know. And now we have a few other ratios to mention. And so something worth mentioning here, okay, relationship that I'm not going to give you a memory device for it, but something that worth mentioning here that you'll get used to over time. And you can put this on a note card or find some other memory device for it if you like, but to compare these things, one thing to get used to, and you know, they all got reasons they have their names, and we can talk about that over time. But with Sohcahtoa, we know So stands for sine ratio. One thing to note is that, how should we say this? Well, we could say this. If I do sine upside down, I get what they call the cosecant function. And so, you know, sine is the opposite over the hypotenuse. So if I go hypotenuse over opposite and just flip the fraction upside down, that's the cosecant function. And so some people say 1 over sine, you know, it'd be a good way to define it. And that is a good way to define it. It's the upside down version of the sine there, equals cosecant. Here's another way. That's what I'm thinking. You don't worry about the arrows here. We might use those. I don't know. But check this out. We'll say this. Cosecant, CSC is the way we abbreviate that. Cosecant is upside down sine. There's sine upside down of 1 over the sine ratio. So that is hypotenuse over opposite, you know. And then the secant ratio, SEC, the secant ratio, is the cosine upside down. And then tangent is cool because it's cofunction. Cotangent is also its reciprocal. And so we'll say cotangent, COT, short for cotangent, is actually an upside down of tangent itself. That's tangent upside down. Few definitions to get used to here today. Again, Sohcahtoa takes you pretty far, and these ones you'll get used to by just using them with respect to the other ones. Anyway, so if cosecant is upside down of sine, then we could say, well, what was our sine ratio? That was opposite over hypotenuse. So we'll go hypotenuse over opposite. Hypotenuse over opposite would be 193 over 95 instead of 95 over 193. 193 over 95, that's cosecant. Remove this thing here. Cosecant, that's 193 out of 95, you know? And then secant is upside down of cosine. So then whatever, adjacent over hypotenuse. So hypotenuse over adjacent. Hypotenuse for adjacent, 193 out of 168. And then cotangent is upside down of tangent. Tangent is, you know, for Toa, from Toa it comes, was that opposite over adjacent? So we'll go adjacent over opposite. Adjacent over opposite, 168 over 95. Oops. There we go, 168 over 95. That's what they're looking for here. You can reduce them if you like. I wouldn't worry about it. Looking good. Okay. All right, what else we got? What other adventures do we have? Same kind of thing here. And then similar here, although notice there's a side missing. We should probably do that one. Okay. We didn't do that on the last one today. Oh yeah. So we can do either one of these last two. Check this out. Okay. So we started on question 10. Let's do that one together. This is recording, right? Yes. Okay. So okay. If they said the length of side A is 72, A is 72 units across, up and down, and then B is 65, Well, they didn't give us the third side. They didn't give us the hypotenuse side. So, you know, from section 1.1, if I got two sides and I got to find a third side, we can probably go Pythagorean theorem on that. You know, since it's got a right triangle or a right angle in it, we can definitely do that. So let's run some numbers real quick. 72 squared plus 65 squared equals some hypotenuse squared, you know, and we'll call it c squared. Then we'll start running some numbers. That's going to take me a second. Let me get a calculator out here. I always like to waste time during the recording by getting the calculator out that wasn't prepared ahead of time. Okay, so let's go square root of, because we're going to have to square root that in a second. So then this will be, C will be the square root of all that, of 72 squared plus 65 squared, right? I'm going to run those numbers real quick and then we'll get ourselves, actually, well, who cares? Okay, 72 times 72. Let's do it the old fashioned way. 72, 5184. And then 65 squared, 65 and 65. Okay. 65 times 65, I think. Yeah, okay. It's 4,225. And then we'll just add those up real quick. That one plus 5184. There's, you know, farther. There are smarter and faster ways to do this. And so we got 9409. Boom, square rooted is side C, you know. I don't think that's going to square root well. Let's go ahead and find out, you know, square root of 9409. Oh, look at that. It actually square roots well. So that means when you do your homework, it'll probably be programmed to square root as well, to square root nicely as well. So square root of 9,409 is 97, which means this side is 97. Then they're going to ask us to find all these trig ratios for, you know, with respect to angle B. We won't do them all, but I'll get you jump started. So now that we have all three sides, then we'll just look at, oh, they're talking about sine of B, cosine of B, and everything's about B. Well, let's look at angle B and label up our sides with respect to angle B. So here's angle B. That means across from it is what we would call the opposite side. And so here's 65 is now what we call opposite. And then that means 72 is next to it. That would be the adjacent side. Because of course, side C, we already knew was the hypotenuse side. Cool. And now when they ask you for sine or cosine or tangent or any of these other ones, we can do it like usual. I'll just do the first one with you. So, and so then see how this goes. Sine is opposite over hypotenuse. They're asking for sine here. So sine of B is opposite over hypotenuse. So that's opposite 65 over hypotenuse, 97, 65 for 97. 65 out of 97. Opposite over hypotenuse, opposite over hypotenuse. Yeah, that'll work. Cool. And then, you know, keep going. That being the case, it's the same kind of thing on the last problem. Let's look at this one. They give you A and C. So the only thing different about this one is they give you A is 105 here. Let's annotate that real quick. Length of side A is 105. The length of side C is 137. So they give you the C side this time. So you'll do it the same way as before, but just remember this is going to be 105 squared plus some B squared equals 137 squared. Run your numbers, you know, and then you'll have to minus this over to the other side like we did in whatever, section 1.1 probably, you know, and then you get B squared equals something, and then B equals the square root of that. But just, you know, don't forget it's a minus this time and then fill in your blank here. I'll bet you it'll come out nice. If it doesn't, you can always leave the radical on it, you know. Cool. Anyway, you guys are doing great so far. Let me know if you need anything else. I'm going to see. Oh, yeah. Check this out. I think I can stop recording just like this. Nope, still doesn't work. I need this. Oh, well. This is getting embarrassing at this point. Okay. We try.